In this lecture, we talk about exponential functions and logarithmic functions. What do we mean by exponential function? Exponential function is a function that can be written as f of x equals a times b to the power x. And you may studied this before in college algebra and other courses, but this is just to remind you of this class of important functions. So f of x is a times b to the power x, where a and b are constants, and b is greater than 0 and b cannot be equal to 1. This is a restriction on the constant b. Now a and b are unknowns, so how to find a and b? We need two equations. Now, how to find these equations? Now let's look at the function here. F of x passes through 2 points. Then we can use those 2 points to find the formula of the function, or the exponential function, the equation of the exponential function. Now before that, let me remind you of a well-known exponential function. F of x equals e to the power x. E here is a constant. E has a value approximately 2.718. So it's constant. And the difference between this and what we learned in polynomials is that polynomial has a variable raised to some power. But here we have a constant raised to some variable power. And that's the difference between exponential and polynomial. Okay, now we want to solve our problem here to find an equation for this exponential function. So here we start with the first point. We are given that the function passes through this point. That means it satisfies the equation. We can plug those values into the equation of the function. So this is x, this is y, and plugging here into star, f of x is y. So y is 6 equals a times b to the power x, x is 1. This is the first equation. And the second equation comes from the other point, 2 and 18. So y is equal to a times b raised to the power 2. And then we need to solve this system for a and b. So we can divide 2 by 1. So we divide the left-hand side by the left-hand side. We have 18 over 6. And the right-hand side by the right-hand side. AB squared over AB. And then 18 over 6 is 3. Now we cancel A. We cancel B. We get B. So B is equal to 3. We found the first unknown. Now we plug this into one of the two equations to find A. Let's plug into the simpler one, which is A. So we have 6 equals A times B. B is 3. And then we divide by the coefficient of A. We get A equals 2. Now we know the unknowns. So f of x equals A, which is 2, times b to the power x, 3 to the power x. This is the equation of the exponential function. Now let's do another example. This is x, this is y. So we use this point, and the equation has the form ab to the power x. So 3 halves equals a times b to the power x, x is 1. This is the first equation. And we use the second point. This is x, this is y. 3/4 equals a times b to the power x. X in this case is 2. So we have two equations. We divide 2 by 1. So the left-hand side is 3/4 divided by the left-hand side of the first equation, which is 3 halves, equals, now the right-hand side of equation 2 divided by the right-hand side of equation 1. Now we can simplify. If you remember, if you have fraction divided by fraction, you can start with the fraction at the top, and then the division becomes multiplication, and take reciprocal of the denominator. Equals, now we cancel a from the right-hand side, we cancel b, we are left with 1b. Now 3 times 2 is 6, 4 times 3 is 12, equals b. That means b equals 1/2. Now after finding b, we can plug into 1 to find a. So a times 1/2, and then we divide both sides by 1/2. So a is, the top is 3/2. The division becomes multiplication, and we take reciprocal of the denominator. So we have 6/2, which is 3. So the equation is f of x, or the function is f of x equals a, which is 3, times b 1/2 raised to the power x. Now let's study the logarithmic functions, and this is one of the functions that you studied before, but let me remind you of important things about it. Logarithmic function is a function that can be defined this way: log base a of g of x, some function here inside. And this is a good representation of the power of a function. For example, in the exponential form, we have 3 squared equals 9. This is exponential form. And now if we can express the power as log base 3 of 9. Good. Now we need to remember some properties of logarithmic functions. We need to remember that log base a of 1 is 0. Log of 1 is 0. We need to remember that log base a of a, same number here, is 1. We need to remember that if we have log base a of x to the power n, we can bring the power outside the log, and we get n log base a of x. We also have one of the properties that says a to the power log base a of x. We can get x from this, and log base a of a to the power x is just x. You may imagine that you can cancel this with this, and you are left with x, and this with this, and you are left with x. And there are some other properties, but we may focus here in this lecture on 1, 2, and 3. And you need to remember some notation. Notation is that if you have log base 10, we don't need to write 10, we just write it as log. And if we have log base e, we don't write it as log base e, but we write natural log. Okay, now let's go to our problem here. The last thing to remember is from algebra. If you have 1 over x to the power n, you can bring this up to give x to the power negative n. We change the sign of the power. Now let's graph this function. F of x equals log base 4 of x. We make a table, and then we choose 1 in the middle, and then we choose 2 values greater than 1, 2 values less than 1, or more. You may choose more than 2 values. Now what is the base? The base is 4, and then we find one of the multiples of 4. Let's choose 16. And at the other side, we take reciprocal of those numbers, 1/4 and 1 over 16. Now we want to find f of 4. Log base 4 of 4 is 1. So here we have 1. Now log base 4 of 16 is log base 4. We need to write 16 as 4 raised to some power. And then we can bring this down here, and using property 3. So we get 2 log base 4 of 4. And then using property 2, we know that log base a of a is 1. So log base 4 of 4 is 1. So 2 times 1 is 2. Now what is log of 1? Log base 4 of 1, it's 0 using property 1. Now the other values, what about log base 4 of 1/4? We can bring this up here to get log base 4 of 4 to negative 1. We always try to write this expression inside the log as the base raised to some power. So 4 to negative 1, we bring it negative power, negative 1 here. We get negative log 4 base 4, and here this is using property 3, right? So this is negative 1. Now what about the last one, log base 4 of 1 over 16? We can write it as log base 4 of 1 over 4 squared, because 16 is 4 squared. And then we bring it up, we get 4 to negative 2. Then we bring the power in front of the log, we get this, but we know that actually this can be done using 3, and now using 2, log base 4 of 4 is 1, so we get negative 2. And some students in exams, quizzes, they want to invest their time, so they just look at the one part of the table. So we have 1 and 2, and then they change the sign on the other side. Now, after finding these or doing these computations, we can graph the function. Now, to graph the function, this is the x-axis, this is the y-axis, and let's start with 1 on x, and then 4, and then 16. And here the powers, we have 1, 2, -1, -2. So 1 has image 0, 4 with 1, 16 with 2, and 1/4 is, let's say it's here, and 1/16 is here. 1/4 has -1 and 1/16 has -2. So the graph looks like this. So this is the graph of log base 4 of x. As you can see, the graph is increasing because the number a is 4, is greater than 1. That means the function f of x is increasing. And one of the properties is that it crosses the x-axis at x equals 1. Now let's do another example. I'm going to change this number to the base into 1/2. Now let's graph this function. To graph this function, we make a table. And we choose 1 in the middle, and then let's choose 1/2 the base, and one of the multiples of the base, and the other side of the table we take reciprocal of those, we get 2 and 4. Now let's do our computations. We want to find f of 4. F of 4 is log base 1/2 of 4, which is log, okay, let's start from the right hand side. It's easier to start from the right hand side. So 1/2, this is equal to 1. Now what about f of 1/4? Log base 1/2 of 1/4. This is log base 1/2 of 1/2 squared, because 4 is 2 squared. And then we bring it up, we get log base 1/2 of, okay, so let's write it this way. No, I don't want to bring it up because the base is 1/2. So we want to write this as 1/2 raised to some power. So this is 1/2 raised to the power 2. And then we bring this down using property 3. We get 2 log base 1/2 of 1/2. But this is equal to 1 using property 2. So we are left with 2. So the numbers here are 2 and 1. What about log 1? Log 1 is 0. Now what about 2? 2 should be -1, and 4 should give -2. And then after doing that, actually, if you want to find log base 1/2 of 4, for example, you can do it this way. 4 can be written as 1/4 to -1. We can bring it down and change the power of 4. And then we have log base 1/2 of 1/4 to power -1. The -1 is for the whole expression. And then log base 1/2 of 1/2 squared raised to the power -1. And from power to power we multiply, so we get log base 1/2 of 1/2 to -2. And then we bring this here to get -2 log base 1/2 of 1/2, and that's equal to 1. But you don't want to do these computations, ugly computations. You may use that observation. If you have 1, 2 on the right hand side, you just change the signs of these numbers. Now we want to graph this function. This is x and this is y. Now we have the points 1, 2, and 4, and we have 1/2 and 1/4. So we have here 1 and 2, -1 and -2. Now at 1/4 we have 2. 1/2 we have 1, and then at 1 we have 0, at 2 we have -1, at 4 we have -2, so the graph looks like this. So it's decreasing because the base is less than 1. Now the last thing is how to convert from exponential form to logarithmic form. Here we have exponential form, and we know that logarithm can represent the power. The power is 2, it's logarithm. What is the base? The base is 4, and we put 16 here. Similarly here, what is the power? -3, it's log. What is the base? Is 10, we don't need to write it, and we put 0.001 here. Now here we have logarithm, and we want to convert it into exponential form. So what is the base? The base is 7. What is the power? Logarithm is the power, it's 0, and we put 1 here. And here for the last one, let's say this is equal to x. Now the base is 0.4. What is the power? It's x. This is equal to 0.16.